Very good. We are going to do some IMSO problem. What does IMSO stand for?
International Math and Science Olympiad.
International Maths and Science Olympiad, and this is meant for upper primary school students. That means year 5 and year 6, right? Year 5 and year 6, primary school level. Now here we have a problem, and the problem is I have a candle here and I'm going to let it burn. So as I let it burn, I will have to light it. I will have to light it. And I have the lighter. Yeah, burner. Yeah. I light it up. So when I light it up, what happens? It gets lighter now. Nothing happens. It gets lighter, okay? And then I will pour water by the side. Now first of all, why is it lighted? Why it continues to light up? Why do you know? Because the surrounding air contains what?
Oxygen.
Oxygen. So oxygen is the gas that supports combustion. Oxygen cannot burn, huh? Otherwise we light this, the whole place will burn up, right? So we say that oxygen supports combustion, but itself, it doesn't burn. That means you light oxygen, oxygen won't light up. But the gas stove can burn. Huh? The gas stove, the gas there, you light the gas will burn. But oxygen will not burn. Those gases that can burn are called what kind of gas?
Inflammable gas.
Inflammable or combustible gas. And oxygen is what gas? It's a gas that supports combustion. Okay. So what we're going to do now, we're going to use a cup first. Okay? And we are going to invert the cup over the flame. You think the flame will continue to burn for a long time? No. Have you done this before? No? Okay. You have not done this before. Invert it slowly. Hold like this and then put it there. Yeah. Good. Can you see right now there is no water inside? And then water comes in. Can you see the water that's inside there? Huh? And the flame has gone off. The flame has gone off. So the question asked, read the question for me.
After a while, the flame goes off and the water level rises in the cylinder. Explain why the flame goes off.
Yeah, explain why the flame goes up. Because there's
not enough oxygen.
No more oxygen.
No more oxygen.
Yeah, there is no more oxygen, and what actually happened is the substance of the candle. The substance of the candle are mainly made up of carbon and hydrogen. Candle wax is known as a hydrocarbon. That means a compound made of hydrogen and carbon. So it's called hydrocarbon. So when the hydrocarbon combines with oxygen in the air, what do you think it gives you? Hydrogen will form, with oxygen you'll form what? Water vapor. Huh? You'll form water vapor. And then carbon with oxygen will form what? Mainly carbon dioxide. There might be some carbon monoxide, but that is not important right now. So we have water vapor which can condense inside, huh? And then we have carbon dioxide. We know that carbon dioxide is slightly soluble, and when carbon dioxide is soluble, it forms an acid called what? carbon 4, carbon dioxide, carbon dioxide will form what type of acid? Starting with C. It will form carbonic acid. C-A-R-B-O-N-I-C. Carbonic acid. So actually inside the water here, it's going to be slightly acidic. Then how do I know? What can I do? I use, what's this? This is called UI. Yeah, this is called universal indicator. Universal indicator. What's the color of UI?
Green.
The color of UI is green. Oh, green. Okay. Now what I want you to do is drip some of this UI around the glass. Drip it around the glass. Not around also. This side. This side also. Yeah. Okay, that's good. That's good. That's enough. That's a lot of UI. Now, what we are going to do is we are going to see what happens. Okay. Now, but before that, we want to mark how high the water rose, right? So the water rose up to here. Okay? Can you mark the other side? The water rose up to there. Okay? And after that, we want to see how high the water rose up. And you know what will happen if I put this for a long time? How long? Many hours, maybe 2 hours. But then we don't have 2 hours. So, before you came, what actually happened was, I did this. You can also see this. And it becomes something like this. Yay! And you can see that the water has rose into the cylinder about 20%. I marked the internal volume as 20, 40, 60, 80, 100. So oxygen has been used up, and then water disappears inside the liquid, and carbon dioxide dissolves in the water, becomes carbonic acid, and carbonic acid in UI will turn the green UI what?
Orange.
Yellow or orange. Yay! It turns a UI yellow or orange. So we know that carbonic acid was formed. If you don't believe that carbonic acid was formed, we are going to ask you again, you have done this before, but we're going to ask you to blow into this green UI your axial breath. So we blow into this green UI your axial breath. What do you think will happen? Take one. Yeah. Okay, what do you think will happen? Wow, we shall see, okay? We cover this. We turn this around a little bit. Okay, put this inside. Put your short inside. Cover this. And blow. Yeah. Not so hard, huh? Yeah. Now your exhale air will contain 4% carbon. Stop. Can you see it's now yellow turning into orange. Okay, you blow some more. And it's going a little bit pinkish and reddish, right? Put near the camera for the camera to see. Some more. See whether it can blow until you're pink, you know. Wow, it's almost reddish right now. Can you see it's reddish? Yes. Okay, that's good, that's good. That's fine. So what actually happened is your carbon dioxide has dissolved into the water, and your exhale air from your mouth has 4% of carbon dioxide, and that 4% of carbon dioxide can dissolve to form carbonic acid. And carbonic acid is a weak acid. You know why it's a weak acid? Because if I were to heat this weak acid, heat this weak acid, you know what will happen? You know what will happen if I heat this? Let's switch off the lights there first. I should use a holder, but never mind. Oh, I can improvise a holder. I can improvise a holder. Yeah, you must learn to improvise things. Huh?
The plastic melts.
No, the heat will not go all the way up. Believe you me, it will not. Can you see? Now I'm going to drive the carbon dioxide out. And when this carbon dioxide is driven out, the orangey green UI will become what? First it becomes what?
Yellow.
It becomes yellow. Can you see the top has become yellow? Can you see the top has become yellow? And if I continue to heat the top can become green. Can you see it becomes green? Yeah. There you are. That shows that carbon dioxide is a weak acid. Huh? And weak acid, the gas can be easily dispelled. Yeah, I forget. One of these days we are going to smell ammonia. We're going to smell ammonia. Smell what? Ammonia. Okay, so you can see that this is greenish now. Huh? It's almost greenish. I think it's greenish. Is it greenish? Yeah, it's greenish. Okay? Yeah, the top is orangey. So that is exactly what happens when we have UI inside the beaker of water. There was no water in the first place. When you put the cup in, or the cylinder cup in, no water went in, right? Because it was air. There was air. So after the oxygen has been consumed, 21% oxygen has been consumed, the 21% becomes a 21% less. So it becomes a, what kind of vacuum? It becomes a partial vacuum. Is that clear? That's the second question. What does the second question say?
Why does this result in the water level? Why does this result in the water level rising?
Well, I can't hear you very clearly, but never mind. Let me read. Huh? Why does this resulted in the water level from rising? Okay? Because a lower pressure is produced when the oxygen is consumed, and the atmospheric pressure will press on the outer water, which is green in color, you can see, and that water will then go in to the cylindrical, what do you call it, a cylindrical inverted glass. Okay, yeah. So this is a fantastic way of showing that oxygen is used up, carbon dioxide is produced, and carbon dioxide forms carbonic acid as indicated by the UI. This is one step further than most people will perform this experiment. Yay! Good. Thank you. We'll put this in YouTube. Okay.